context API couldn't kill Redux. So Jason Rhodes a couple months ago gave a talk about some of the new changes in React 16.3. And one of them was that the context API is now stable. I'll explain what that means in a second. But one of the things that I spoke to a couple people afterwards at the bar about was, people have largely used Redux in the past, or very many people have used Redux in the past, as essentially a stable layer on top of the React context API so that they could have global state in their React applications. And so, given the fact that the React context API is now stable, why are we adding another library in order to manage local state? Why can't we just use the React context API? So basically, I'm going to show a pattern that I use in Redux, which can't just be done with the context API, which is really the reason that I use Redux. So let's go over what context is. Context is a API provided by React. It gives you a provider, which is going to sit somewhere at the top of your component hierarchy tree. So it's going to be towards the top of your app, towards the top of wherever you're going to need that state. Other components can subscribe as consumers to that context, and it provides them, it allows them to pass props essentially all the way across the application. This prevents prop drilling, where you have one little prop that you need to get from here to here, and you got to pass it through all the props, and if something goes wrong along there, you get into some big issues. And it recently became stable. It's only a couple months, but in the JavaScript world, that is beyond. So, what is Redux? Redux wraps this API, so you have all the things that we just talked about with the context API, but it gives us a single source of truth. So you only have one Redux store in your end. You're not going to litter them all over the place. State is read-only. You can't directly modify the state, or you're not supposed to. You can technically directly modify the state, but that's completely against the purpose of Redux. Changes are made with pure functions. Again, there should be no side effects in your reducers or in any of the functions that change your state. So this is basically, React has a one-way data flow. You always start from a higher component, you start passing props down to lower components. And Redux tries to enforce that by creating a loop that comes all the way around and keeping that data flowing in a single direction. So last time I spoke, I said this too, but this is something that I really believe. User interfaces are inherently event-driven experiences. Something happens on the page, we do something in response to that. We're not very often running code in the interface without anything happening. Or, we may be having some events that are happening in the background, but we're not, it's really we're reacting to things that are happening on the page. So, let's give an example. We have a button that's clicked. That button is then, let's say we're using the context API to update something in the context. The component is going to re-render. We can click another button. This is essentially our loop of events that happen on our page. So this can be, so when the button is clicked, the form field is updated, anything that's going to change our state, we're going to maybe perform an asynchronous action in response, maybe update the state, maybe re-render the component if there's new state. This is essentially the flow of how it usually works. So this is what Redux provides us. We're going to start off over here. The people on that side there can see me, but we've got our view. This is going to be a React component. Say a button is clicked, it dispatches an action. That action is passed to a reducer, which decides based on what the contents are in that action and what that action is, if it should produce a new version of the state. And then that then returns the new version of the state into the store, which is passed to the view. So we get our loop here. We're adding a couple things over here. We have our action, we have our reducer, and we have our store. And I'm going to explain why those are important right now. So one thing I didn't really cover is how we use side effects. Because in Redux, we can't have side effects in our functions that produce our store. We can't call an API from a reducer. We can't call some other part of the program. We can't affect anything. It's supposed to be some argument is passed into the function, and something is returned purely based on that argument. So there's a couple ways we can do this. We can use Redux Dunk, we can use Redux Saga, or we can write good old middleware from scratch. And Redux Dunk is adding additional functionality into your action function. Redux Saga, I really can't tell you how it works because I have no experience with it. I just heard some people like it.
Rad.
Super rad, okay.
Yeah.
Redux Saga is super rad, but I like the little middleware better.
Basically, think of cancelable async.
Okay.
And the chain and parallelism.
Cool. All right, I'll look into it. But I'm going to keep going with my whole middleware pattern because there's a specific pattern that I want to expose from this. So this is how the Redux store actually works. Something happens in a view that calls an action. That action is then passed again across all of the middleware that you have in your application, which can make whatever side effects it wants. When it's done, it dispatches another action that hits your reducer and goes to the store. So this gives us a construct outside of our component to do whatever asynchronous side effect actions that we want to do. And Redux Stunk really does this. When you dispatch a action that has an asynchronous event, like something that's doing it inside of that action, what Redux Stunk does is take that asynchronous call, take that function, and wrap it inside of the middleware wrapper. And then you can, at the end of it, dispatch a new action. And it gets a little bit cumbersome. So let me show you a little bit of code. All right. So over here we have an app that has a single important component in it called the counter. Ooh, that is really getting right this way. So there's our counter right in the middle of the provider. That counter component, when you click on a button, it calls our action called increase, and it provides the number in state that is provided to it plus 1. That's on line 9. And our reducer over here for the counter simply says if we got an increased counter, let's return whatever number was passed to us. So we're really not doing anything in this reducer. And if we got a reset counter action, we're going to return the initial state. We're going to reset it. So this is very basic, and it works. It works for us. There's nothing wrong with this. But the problem is, as you begin doing more things, as you begin hitting your API, you start ending up with, well, you have to put that code somewhere. So we're going to put it into the component and only dispatch something afterwards. And it starts getting very messy. So we can switch to Redux Stunk. And in Redux Stunk, we see we have the same thing in our reducer. The difference is in our action. And our action over here looks like this. So it's a function, it's an arrow function, ES6 stuff. Something is passing in dispatch and get state. There, but that's not even there. I'm looking for format here. But little bug. And then it dispatches get state.counting number, so the counting number from the state plus 1. So we're moving the business logic, moving the calculation out into another file. This is great. This helps us, make things a little bit smaller, make things a little bit easier to read. But the problem is, I'm defining this whole dispatch thing here. I just have dispatch and get state. I can't really control whether this action is going to get passed on to another middleware. Maybe I want to prevent it from doing that. Maybe I'm just trying to call a middleware through an action. This is okay, but after working with Redux Stunk for a little bit, I started getting these really, really messy action files, and it's starting to get a little bit annoying to deal with. So let's check out, let's see what a middleware would look like that would do this. So we have our increase counter over here. It just says increase counter. We don't have a payload with that. We also have a counter increase action, which carries a number as a payload, but it's just passing that through as an argument. It's not doing anything here. Where all of this is calculated is inside of the middleware. And right here, called increase. And that's all it is. We import increase counter from our actions file. Okay, so we import increase counter. This is the action we're looking for. We import increase, which is an action that tells us that this state was modified. Here's the new version of state. This is the signature of a middleware function. It gets the first argument is the store, which is this path to get state. We then have next, which is how we pass the action on to the next piece of middleware. We can prevent this action from continuing by not calling next. And then we get the action. So the first thing we do is, because I have no reason to stop this, pass it on. And we can handle our own our stuff on the side. There's no reason for that not to continue. If the action type is increase counter, we're going to dispatch increase with counter number 1. So we're really breaking this up into a command saying, hey, increase this, and then we have a function which says, okay, what's the number we need to increase? What are we increasing it by? Let me increase this, now let me say that it was increased. And what this gives us is a very predictable, let's zoom out of this for a second so I can actually see what we're doing. It gives us a very readable debugger. So the Redux dev tool is actually really, really powerful. And we can see every single action that's happened. So we can see that something asked for something from an API. Now that hasn't finished yet, but I know that it's asked it, and I can look through my debug logs, and I can see that that was asked for, and then I can see when it came back. And so you really get a very good view into everything that's happened in your components, when it happened, and what was going on around it. So this is our counter. We're going to increase it a couple times, reset it, increase it a couple more times, and now we can open the Redux dev tools. Okay, so it's not going to let me. Okay, I think this is readable. So we can see we have an increase counter action, which just has a type. Then we have a counter increase, which has the payload and the number that it was increased by. And this gives us really good visibility into commands and reactions in the system. So that's all the sample code I have. Let's get back to the application. So this is very similar in terms of how we're computing state to an accounting ledger. An accounting ledger has to be really exact and always reliable. And the way we compute an accounting ledger is everything, purchase acquisition, all these different things, anything that's going to affect our balance comes into the journal, which keeps essentially an event log of all the things that have happened in the system. That then gets compiled into a ledger, which produces a trial balance, so what that account should be at. We can make corrections, we can go through this loop. So this would be our actions. This is our middleware over here. This is where we're deciding, based on this action that happened, what do we now need to do with this state? And then we can produce our reports, and that's really what our state store is. It's a report of what's the state of the system now. So we have an action that happens because the button was clicked. Our middleware then says, okay, when this happens, we got to do X, Y, Z. We do all these different things. We're separating this out into a separate entity, and then it can then produce our report of the state of the system right now, which is reflected in the UI. So this makes a really predictable pattern. And I have a little quote here from Robert Marty. In order to make sure that our functions are doing one thing, we need to make sure that the statements within the function are all at the same level of abstraction. So this is one of the problems with Redux is that you're handling an action and you're handling the result of that action at the same time. Using this pattern, we're able to separate the action, define actions as essentially interfaces on events. And then we have the response to that. We can have 10 responses to that. We can have one that changes another one. That's completely separate from the action. And what the responses are set, even though the middleware, even though they're dependent on the schema of the action, they're not so much tied to the action. This really separates things for us. This is actually not a new pattern. This is called the subpattern, publish subscribe. It was introduced, and I cannot remember by who, but in some paper in 1987, and it's been used since. You can use it on the server. There are many different libraries for it. Sorry, I can't remember the name. You were telling me about a couple of them earlier. I heard a talk from somebody recently about Apache Kafka streams that really cover this pattern very well. It's a very similar thing on the server. So, publish, subscribe to the messaging pattern. The idea is that senders of messages, our publishers, do not program the messages to be sent directly to specific receivers, which we're going to call subscribers. So, we're not specifically sending this message to a receiver. They categorize the message, and subscribers can choose to listen for this specific type of message. Subscribers express interest in one or more types of messages or classes, and they only receive those messages without knowing about the publishers or any other subscribers. That's the idea of this pattern, and it gives us two things. It gives us loose coupling, because they're not coupled together. They don't know about each other. If I want something else to happen, if I want to add an analytics middleware, I can simply say take every action that has a meta attribute and log that to my analytics. It doesn't have to be specific to a single action. And an action, I don't have to touch the action in order to do that. So that gives us really loose coupling. Scalability is another thing. Because they're not coupled, the system can easily scale both encoded and hardware. In hardware, there are, for example, Apache Kafka streams. We're able to distribute this among many computers, which essentially, think about it as they're acting as our middleware. In code, the thing that I found very helpful in my code base is that if I need to add another feature, I just need to listen to that action in a different middleware. I add another middleware named with that feature, and I listen to that action and I do what has to happen. I don't have to worry about touching other code and breaking other code, because every single thing that's happening is isolated. So, the way I like to think about these actions is they're interfaces for an event. An action describes an event that occurred. It can have a type, payload, metadata, whatever else you want on it. Middleware subscribe to that to an event attribute. It doesn't have to be the type. It can be any event that has this type of thing on it. I want to respond to that. Neither events nor middleware are aware of the other middleware in the system, and this allows for very modular applications and a shorter development cycle for your future features, because things aren't coupled together. You can develop independent features of each other. It provides us with loose coupling and scalability, the same thing that the traditional hub-sub pattern gives us. Individual middleware is not dependent on each other. They're designed to respond to an action regardless of the dispatch bit. And they're scalable because all of our business logic happens in middleware that's self-contained. So there's no significant effort in adding, changing, or removing modules. So I'm not the first person to use this in Redux. I actually got most of the ideas for how to use it. I don't quite use it the same way as them, but most of my ideas from these two talks on YouTube. And I'm going to share my slides afterwards if you guys want to watch them. I don't think that works the way being copy-pasted out. Advanced React Patterns, Redux Patterns by Peter Kaufman, and Practical Advanced Redux by Boris Stankovic. Really great talks where they have an hour each to describe this pattern, and they go into a little bit more detail than I did. I'm going to leave you guys with another quote by Bob Martin. You can tell I really like the guy. And that is really why, this quote is really one of the reasons I focus on this pattern. And that is the first value of software, which is behavior, is urgent, but not always particularly important. We need the software to work, but the fact that it works isn't so important. The second value of software, architecture, is important but never particularly urgent. So to the software itself, the architecture that's used to write the software, the fact that it's loosely coupled and you can keep adding to it and that's going to be stable, is far more important to the piece of software than the fact that it works, even though the fact that it works is why you're building the software. So we often brush this over because it takes longer to set up at the beginning, but it's really the thing that we can make a program work in any million types of ways, but we really have to think about how can we design the system, how can we design the components so that they're going to be maintainable over time, so that we can keep working on this project without slowing down our development time as we continue going through it. And I think that is the end.